Hey there, you right. For this example, we are looking at finding the x and y intercepts. So in our lesson, the x and y intercept, remember, it is to find when does this straight line, so each and every one of these equations, remember, they are a straight line. So this is a straight line if you sketch it, and this is a straight line when you sketch it. Right? Now, what you don't want to be doing is to do the table of values, which is what you did in exercise 9b, where you write down a table and you worked out using the equation and you plotted 5 points. It takes too long. You only need 2 coordinates, and these 2 coordinates are the x and y intercept to sketch a straight line. Okay, so what I'm trying to say is 3x minus 6. Okay, if I just open up my Desmos, so you can do the same. You can go to Google and type in Desmos, okay? And the first link with the graphing calculator is what you can do. So you can actually visualize what it might look like. So in our case here, we've got, let's go back here, 3x minus 6. So if I type in y is equal to 3 times x minus 6, if you're wondering how I got the times, you don't have to put it in yet. You can just type 3x minus 6 and I'll understand. But can you see that here I already got the graph and it's a straight line, but what's the x-intercept and y-intercept? You see the x-intercept right now is 2, 0, and the y-intercept is 0, negative 6. So those are the 2 points that you can see that is part of the graph, and that's all you need in order to sketch a straight line. So I'm going to show you this algebraic technique to get this graph. Okay, so unlike what we did in exercise 9b, where you just simply looked at a table or you created a table to figure out a bunch of coordinates, you don't need to do that now. So I'm just going to copy and paste this here just so you can see what I was doing. So I'm going to just copy this here and I'm going to move this graph down so we can see the comparison. Okay, so I'm just going to put it here. There we go. Let's have a look. So how do I find my x and y intercept? So we know that according to our x-intercept right now, it should be 2. So this is the x-intercept, 2, 0, right? And then this is the y-intercept. We know that coordinate there is 0, negative 6. Now, what's the pattern? The pattern is that every time you have an x-intercept, so I'm going to write here, an x-intercept, okay, every time you have an x-intercept, you notice that the y-coordinate will always be 0. That's one of the key things about calculating this. And then same thing that when you're trying to find the y-intercept, I'm just going to make this a bit skinnier. So the y-intercept, the pattern is that the x-coordinate will always be 0. Okay, because that's where x is 0, whilst the y value is always 0 here. So this is what we're going to do. To find the x-intercept, I'm going to write here as part of your calculation. So please use these layout that I'm doing. So when you're finding the x-intercept, what I want you to do is to remember that the x-intercept, we know that the y value is always 0. What we don't know is what the x coordinate should be, because it could be anywhere on the x-axis, right? It could have been any of those values there. We just don't know which one. Now, we know the answers too, but say if I didn't give you that graph, how do you figure it out from the equation? Well, since these are the only 2 things we know, x is x and the y value is 0, we substitute this in to the equation. So x will go with x and 0 will go with y. So if you do that, this now gives you 0 for the y is equal to 3 multiplied to x, which we don't know what x is, so we're going to leave it as x, minus 6. Now remember, back in your chapter 5 and chapter 7, you have to learn how to sketch this equation, solve this equation. So this is where you would do your balance the equation, add 6 on both sides because that's a minus 6. Negative 6 plus 6 cancels out to be 0. Okay, or is 0, and then 0 plus 6 is 6, and then you've got 3 times x minus 0, which is really the same thing as saying 3x is equal to 6. Okay, so this is where I was saying that learning your algebra is going to be important because this is what you're doing here. And then finally, how do you find x again? Notice this is 3 times x, so the opposite of times is divide. And what am I dividing? Instead, that's times 3, so it is now divide 3. So I divide 3 to both sides, and you can see that 3 divided by 3 on the right-hand side is 1. And 1 times x is x, while 6 divided by 3 is 2. Okay, so what that tells me is that the x value, see this x value is 2. That's what it tells me. So that's why we know, therefore, when x is 2, y value was 0. True, when and the y value was 0, we found out that the x value is 2, which is exactly what I have over here. Can you see that? So I didn't even know, or I know because I sketched it for you, but if you didn't have the graph with Desmos, you can still calculate it using algebra. All right, so now if we want to find the y-intercept, the pattern is quite similar. So the y-intercept, we don't know what the y value is. Okay, we don't know we're on the y-axis, but we do know that the x value is going to be 0 on the y-axis. So again, our equation, remember the equation they gave us before was y is equal to 3x minus 6. So if I wanted to calculate this, remember the y value goes with the y values and the x value goes with the x. Okay, so x coordinate with x, y coordinate with y. So this gives me y is equal to 3 times, now x is 0, and then minus 6. Now this is nice and easy compared to the other one just now, wasn't it? Because y is simply equal to 0 minus 6, and therefore y is equal to negative 6. So therefore, when x is 0, because that's what we substituted in before, right? When x was 0, the y value is now equal to negative 6. You see that? And then now I have 2 points. We were looking for 2 points to sketch the equation. I've got 2, 0 and 0, negative 6, which is exactly the same than what they had over here. But I didn't need the graph, you see. I didn't even need to do the tables. I used algebra, and I was able to figure out the 2 points in your axes. When you sketch it now, you see you don't actually have to lay out what you did in exercise 9b. You don't have to do, let's label 1, 2, 3, 4. You don't need that. You see, all you now need is simply 2 coordinates, and you can estimate it as well. You can say, well, this point here we found was 2, 0. That was the x-intercept. And then the y-intercept, you found out it was 0, negative 6. You see, you can plot it like that as long as, obviously, negative 6 is much longer than 2. So the distance from here to here is 2, and the distance from here to here is 6. As long as it shows that, 2 and 6 do look different, then you can now use your ruler, and you should use your ruler to then sketch. So when I sketch this graph, I'm just going to do it a bit smaller. There you go. And notice though, go past the points because it's an infinite line. The line will continue in this pattern that it seems like it goes up 6 and across 2, up 6 across 2. And we can talk about the gradients later on, but at the moment, that's what I want you to practice. How do you sketch that equation without using the table? So remember back in exercise 9b, I'm just going to quickly go back. See 9b, for you to sketch 3x minus 1, what you had to do was you had to follow this table and you solve for when x is negative 2, negative 1, 0, 1, 2, and you filled out the y value for each one. And how did you find the y value? You used the rule, right? And once you got the y values, you have 1 coordinate, 2 coordinates, 3 coordinates, 4 coordinates, 5 coordinates to then plot in a graph, right? Then that's how you got your straight line, and I told you to use your ruler. See, that takes too long, and it's tedious because you have to label the axes as well. But what I'm showing you right now is considerably faster. What does it rely on though? Your algebra. Okay, so I'm going to do another example just so that it's more straightforward and quick for you here. So let's have a look here. You now have y equals, so part B, you have y is equal to negative 2x plus 1. So this time I'm not going to sketch it on Desmos. We're going to try to find x-intercept and y-intercept first. Okay, so x-intercept. So the x-intercept, we know the coordinates is, I don't know what x is. It's somewhere on the x-axis, but I know the y value is 0 on the x-axis. So this is the x-axis. Okay, any point that you put on the x-axis, there's a pattern. The pattern is that whatever it is, the y value is always 0. I guess that's the pattern that we see. Okay, so I'm now going to say, all right, well, if that is true, well, then in my equation, which is currently y is equal to negative 2x plus 1, right? I'm substituting x with the x and 0 with the y because this is the x coordinate and this is the y coordinate, right? So if I do that, what do I get? So here we go. I'm going to get 0 over here is equal to negative 2. Well, x is still x and plus 1. And then from here, you're using what you learned in chapter 5 and 7 to solve this equation. You're trying to find x, right? So to find x, again, let's remove doing SAMDOB. Remember that SAMDOB? So remove any addition, subtraction first. And I can see that there's this plus 1. So what's the opposite of plus 1? Minus 1. Minus 1 on both sides. And what you get now is plus 1 minus 1 cancels out to be 0. And you now get the next line, which is 0 minus 1 is negative 1 here. This is still negative 2x. And remember, plus 1 minus 1 is 0. So because it's 0, you don't really have to write it. True? And then now from here, how do I get x? So x currently is being multiplied. So be careful here. This is times negative 2. Okay, it's not a minus 2. It's a times by a negative 2. So the opposite of times is then divide. But what am I dividing? Negative 2. So I'm dividing both sides by negative 2, balancing the equation. Okay, negative 2 divided by negative 2 on the right is 1. Remember, anything divided itself is 1. 3 divided by 3 is 1. 4 divided by 4 is 1. So even when you say a divided by a, that's still 1. So when you have negative 2 over negative 2, it's still 1. Okay, don't forget that. That's a very common mistake. So that's 1, and then that becomes now 1x. So that's my 1x is equal to half. What happens to the negatives? Double negatives is positive. So my answer is half. So what does that mean? Remember, you always have to understand the meaning here. This means that the x coordinate is half when we know that the y coordinate is 0. So you got 1 point. That's your x-intercept. Now you only need 1 more point, and then you'll be able to figure out what the graph should look like. So here we go. Let's find the y-intercept now. Now the y-intercept is always much easier to do. So if you like, you probably should do that one first next time. Y-intercept is what I normally tell my students to do first because it's easier. It gives a bit of confidence when you're doing them. So let's have a look at the y-intercept, okay? So y-intercept, we don't know what the y value is. But we do know that on the y-intercept, the x coordinate is always 0. So according to the rule again, y is equal to negative 2 times x plus 1. So I'm going to substitute again. The x coordinate goes with the x coordinate. The y coordinate goes with the y coordinate, right? So this now gives me my new line as y is equal to negative 2 times, what's x again? It is 0. Plus 1. So y is equal to negative 2 times 0, which is 0, plus 1, and then suddenly you're done. Y equals 1. So what does that mean? That means that when x is 0, the x coordinate is 0, we solved that the y coordinate should be 1. So what you have now is you've got 2 coordinates here, and you can now sketch the graph. So you need to rule out your axes. Okay, I'm going to rule out my axes in black. And here we go. So, what happened there? Oops. Here we go. We ruled out our axes. We've got 2 coordinates here. We've got half, 0, and 0, 1. So I'm going to label my axes. I'm going to say this is my y-axis, this is my x-axis, and the x-axis, this coordinate here, 0.5, let's say you can pick anywhere. So you can just, as long as you label it correctly. So if this is half, then I'd say this is 0.5. And then 1 has to be double of that, right? So I'm going to put maybe 1 down here. Oh, sorry. 1 shouldn't be there. Y value of 1 should be up here. There you go. So I call that 0, 1. So I don't even have to measure the axes. You see what I mean? And all I do now, as long as you've labeled it, use a ruler and you sketch. I like to put an arrow at the end of the lines because that indicates that it's infinitely going on. So there you go. That's how you sketch using algebra, and that will help you practice exercise 9E, where they said for the graphs, for the rules, find the x and y-intercept. What I actually want you to do is do what I just did before. For each and every one of these equations, I want you to find those x-intercept and y-intercepts and sketch. Okay, so I do want you to do all these questions here, 1, 2, and 3. Okay, so exercise 9E, do 1, 2, and 3 so that you get a good practice of your algebra, but also start to understand that when you get these equations, they're all straight lines, and to see the pattern on how to find the straight lines, and you'll start to see actually it's really, really easy to do once you've got your algebra sorted, because the hardest part is this section. Your chapter 7 helps you to solve that. That's what you've been training to do. Okay, so as long, and that's why I'm saying clear layout. See how I lay things out? It's very clear. This is one of your first times putting it all together, which is why it's important. So I hope this video helps you understand what you're doing here. Please have a go with this, and I'll make another video for this one too. Same idea, find the x-intercept, y-intercept, and then sketch it. Same pattern. Okay.